Okay, we are now going to append elements to this number. First, let me demonstrate appending a number of type of stream to this str. Then we will explain in detail what this passage means. First, we need to be a bit clear. The TArray we are talking about is actually located here in our core under the public files container called Array.h. You can see many containers here. Our screen list, map screen, then set, bees and their union. Right, then we will mainly discuss array and set and map because we use it the most. Other times, you need to look at it based on your business scenario. You can just look at it when needed. And over here is its focus. It is a dynamic host, right? And next are the templates. It is templated, but dynamically sized, and all your elements can be allocated. And you must explicitly, if there isn't a constructor, you have to move it to a new one. You must explicitly move it to a copy of this constructor. Explicitly move over. So if you want to implement this, you need to go to the element pointed to by this pointer. You must be invited. It should be historically invalid. Right. Anyway, this is the definition of the array, and then if you look at it, you can see this spot. It provides many of the methods of these templates, things like constructors, etc. Okay, then note that in other places, there are actually still TLV, but we often use this TLV because the TLV in some places, in different situations, it might use a different kind of TLV. So let's go back here first, okay? Let's put this here first. Let's write this method on it. We use addString. Okay. Then let's add this code. Okay, it's like we spawned a streams array, and then at this point, add two elements called hello world. Okay. Next, let's debug it inside the blueprint. Alright. Then at this spot, on stay, that's it. Then we start it now. We need to set a break. Start. You will notice that after it enters, it doesn't have any elements right now, does it? After we add them, it still has a one element. Its max is directly 4. It's 4, right? Then we'll add another one. Max is 4 now. Colored. Okay, alright, no problem. So we attach it now. Should we add a few more? Let's add a few more. Then we add my city here. Then we write Chengdu. Well, okay, we just wrote something random here. Then next, let's start testing it again. Okay, after we start the test now, we can see here that the first hello word city. This is my city. Let's note. Next, we will press F10 to go in. It also turned into Wuhan D2, right? Proving that it was expanded all at once. Shifting, so sometimes our interviewers really like to ask how your array expands underneath. In traditional CDX, these victory maps in STD, STL, what is its underlying data structure? are they hash or binary tree or array? These interviews, if you encounter particularly skilled interviewers, they tend to ask you these things to test your fundamental knowledge. You can see that if you click into this method, actually it's in this place, adding a new element. It might reallocate the entire host and then fill it up. Then what it drops is APIs. This APIs is actually right here. Let's see if we can dive a little deeper. Let me see if we can go into this area further. We should continue going down to the lower level. I remember it's 16. It is actually in the underlying layer. You can scroll down a bit more. You can then find where the 16 came from. Okay, we will stop here first. Then we will continue to discuss the next thing. And it means that when you add an array, when we exceed its capacity, the memory allocator will add enough memory to facilitate the storage of multiple elements. So ADD and day plans, most of their effects are the same. If there is a difference, it's how they are implemented. Applance. Based on the given parameters to construct a new instance. And add and press, they take this instance. When copied, it first constructs an instance, whether copying or moving into the host. So when you go to create, when creating a string, if you use add, it will create a temporary string. Then move it to the string, and apps directly create an FString, so it avoids creating this temporary string in between. Clearly, for a complex data structure like FString, or for numeric types, then this temporary file will definitely affect your performance. But for basic numeric types like int and float, then it really doesn't matter. So in most cases, this FPS is superior to ADD because it doesn't create temporary variables and copy these temporary variables into a container. So here we use ADD, used for relatively simple numeric types, and Emplace is used for some complex structures and things like that. But we are usually still accustomed to using add because the readability of add is better, because we might have blueprint, we might have person, or we might have C. So in fact, often add is generally seen as a common universal concept. It's a conventional use of add. We are simply adding elements into a container, and then we need to pay attention when we write our own methods. I should try not to use some common things like remove or add, because if you use up this kind of utility service, a problem will occur. This can lead to conflicts sometimes with other modules. That is, if they both have the same method, sometimes there might be conflicts. My personal habit is that if it's a plugin I made myself or functionality, I will add xt like this to distinguish it from the engine, or other languages or other tools, okay? Now let's focus on demonstrating this point, because these two are quite important. If we make a dictionary, then we'll just plug it in. Okay, then let's first define a simple struct. We'll call this one KOgang. Xiaogang, add. It should be called add. Extract. Then we need to give it a read. We can directly use body. In previous versions, you might prefer using ucls, but maybe after UE5, you might actually want to unify it. Everyone can just use body. And then we give it a default constructor. We give it a structure. Then we give it a variable. We don't need this variable for now. Put it into this blueprint, because we are only doing this part. Just doing a simple test out of habit. Here, let's add another one. We give this place a untripsodva inal. Then here we take this. It's also responsible for entering. Responsible until we need to set a date here. Written incorrectly. Right, okay. Then here we need set up a date value we gave it a walling level. We haven't discussed that yet, but we often use it this way, right? Okay. So after writing it like this, after writing it, if the structure is constructed, it will set a date value. Then, at the same time he is absorbed, it will also trigger a day count. So we write one here. We write two methods here. Okay, use pass here. Okay, let's do it here. So we hope to put this host, declare it on the object of our object. Why declare it on the object? Because once this method is finished, if it exists inside the method, depending on its scope lifescope, this array will be released after these parentheses close, undergoing a release. This might affect our logic. So we set its lifetime scope right when EKTR was fading away. We'll perform a release on it, and then we use added here. We should be able to just pass 150 here. Note that we need to change this name. We'll do it this way. Look, there's an error here. What do you think the reason is? This place is stack because it has 3 components. Let's check it again. We use a path. Okay, let's go to our blueprint now and perform a simple test. For testing, we should still perform the test within our backer. This place of ours is apit string away. Let's output another method. Impound strike away. Let's pay attention to the logs. Let's take a look first. Okay. Look, I was drawn, counted, I was released. Then, if we move it here, at this point, you can see he only has 1. I counted it. Why is it like this? It's the sentence that we explained. In this spot, it constructed a temporary object, and then this temporary object, after finishing the process, he moves it. All copies into this array away, and then this temporary object is released. So at this point, it will print a message that I have been released, and this place directly takes 200 to construct an object. This place exists in screen away. Only when this actor dies, we will release it. So we turn it off here. When our game ends, it will then be released. So in this lesson, we are going to give everyone a key demonstration of this A plus and this AD thing. Okay, then let's continue looking below. Let's take a look at this UNIQ thing. This UNIQ thing. That is, UNIQ is an element that only adds a unique value. If it already exists, it won't add it again. So it is not limited to this pointer type. That is to say, not limited to this number type. If I add several new pointers for 8 tours, that is to say, I add 2 pointers. These 2 pointers point to the same actor, then this data structure will actually only have 1 such element. So we will write a simple test for you all. Okay, then let's cover these in the next class session.